Hey, hi, good evening, everyone. Just give me a minute. Right. So, guys, welcome back to our 30 days free short term training from Python to AI. Let me share my screen. Good evening, friends. Right. So, what did we discuss in the previous class? We have completed Python module and we started the next module that is, you know, EDA, exploratory data analysis. Yes. So under EDA, we have understood all the four moments as well as data visualization. So under data visualization, there are actually two different types of visualizations. One is univariate, and the next one is bivariate. So again, under univariate, we understood bar plot, box plot, histogram. Whereas under bivariate, there is only one plot, which is nothing but scatter plot. Good, good friends. So yesterday, we have understood scatter plot, the only bivariate plot which helps us to understand the relation between, you know, two different variables. Scatter plot. The purpose of scatter plot is to understand the relationship between the variables. Perfect. But what does scatter plot talk about? Scatter plot talks about the linearity. Right? Yes, it talks about the linearity. Then, post linearity, it again talks about the direction. And the final one, which is very important, is strength. Okay, so linearity. Under linearity, we are going to observe the scatter. So, is it going to form a linear or non-linear pattern? This is what we observe, non-linear. Whereas under direction, you'll see what is the relation between exact the two variables. Whether the scatter is moving towards the upward direction or downward direction or no direction. So upward is nothing but positive, downward is nothing but negative, and no direction is where we'll understand R is zero. What is this R? So before understanding what is R, we discuss strength, right? Strength is in general, excuse me. In general, strength is subjective. What do you mean by subjective? Subjective is nothing but, Everyone can make their own comment. It varies. It is not same with respect to each and every point of view. Okay, so subjective varies with respect to each and every one. Strength is of again three types. Strong, how strong the scatter spread in the plot. Okay, then moderate spread, and finally, weak. Yes, since strength is subjective, and we can expect n number of answers for the given single plot, but which is not accepted, our statisticians, they have come up with a measure. What is that measure called, friends? What is that measure called? That measure is called as correlation coefficient. Correlation coefficient, which is represented with small r. Yes. What is the range of small r? Range of small r is -1 to +1. Okay. Range of small r is -1 to +1. Right. If I talk about the magnitude of r, if I take only the magnitude of r, it will be from 0 to 1. Obviously, see, -1 to 0 and 0 to 1, both the values are same. But with respect to magnitude, they are same. What about the sign? Sign gets changed, right? So, if I take only the magnitude, it is nothing but 0 to 1. Right? Yes. Now, based on the value of R, the strength got finalized. It was fixed based on the value of R. R greater than 0.85, strength is said to be as strong. R which is less than 0.85, whereas greater than zero point 0.4 is, it is nothing but a moderate strength. R completely less than 0.4 is said to be as weak strength. Yes, good. Right. So based on these thumb rules, the strength has been finalized. But the question is, what if R is equals to -0.7? What kind of strength does the variables have? Is it strong, moderate, or weak? For a value of R is equals to -0.7. Is it weak, friends? Or what exactly will be the strength for the given value of R? Comment. Use the chat. Okay. Will it be weak, moderate, or strong? This is where generally people, fall in the trap. Will it be weak, moderate, or strong? 10 more seconds will be given. Think properly and comment. Okay, right. Sorry. Let me continue. So, what is the question? Question says R is equals to -0.7. So, let me come up with the thumb rules. So, -0.7. Where do we have -0.7? This one, R less than 0.4. So, by just looking at -0.7 is obviously less than 0.4. So, we can make our decision as weak? No, it's a blunder. That's what I'm telling friends. Don't, you know, consider the sign. What does sign indicate? In R value, what does sign indicate? What does sign indicate with respect to R value? What does that mean? What does sign indicate? Yesterday we discussed this point. Sign is indicating the direction. Direction. So negative downward direction is what you observe. So now just take only the magnitude 0.7, which is nothing but which lies between 0.85 to zero point 0.4. Obviously the strength will be moderate, not weak. Don't get confused. Okay, so again the question is R value is minus 0.99. Will it be weak, moderate, or strong? Will it be weak, moderate, or strong? Hmm. How come moderate? See, this minus is indicating direction. So let us ignore this sign. What is the value of R? 0.99. So go and check with the thumb rules. 0.99 greater than 0.85. So obviously this condition is holding true, right? So what kind of strength you'll observe? Strong is what we observe with respect to the variables. Don't get confused, friends. Direction is towards downward, negative. Okay, but the strength will be strong, not moderate. Don't get confused. Fine. So I hope every one of you have also, done with hands-on. Is this done with respect to scatter plot? Done or not? Just one word. Yes or no? No? Done. Good. Now, tell me what is the function that we have used to visualize scatter plot from matplotlib.pyplot? What function did we use? What function did we use? plt dot scatter. Scatter is the function, right? Inside scatter, we are supposed to pass. Scatter is the function. So inside the function, we are supposed to pass the parameters, arguments. Good. How many arguments we are supposed to pass? At least how many arguments does scatter function expect us to pass? Is it 1, 2, 3, or n? How many arguments or parameters it's mandatory that we have to pass? It's 2. Good. X, Y. Why 2? Because if you observe scatter plot belongs to a bivariate visualization, and it's mandatory that we have to pass two arguments. One is X. For X axis, what data you are going to pass, and for Y axis, what data you are passing, you have to mention. And rest of the arguments, parameters that you are passing are, even though if you ignore them, by default the values will be considered Like one of the parameter that we have understood is color. If you mention, yesterday I ignored color, I removed color, and by default we observed scatter in blue color. So even though if I don't give any value for color argument, it executes. The reason is the default color will be taken. But if you want to customize as per your requirement, you have to give a value for color. Okay, but in the same way, ignore one of these two parameters, and run the code. Run the line. You'll see what is it executing. Is it going to visualize any scatter plot, or is it throwing any error? Okay, so this is what we have discussed. And what is the function that we have used to get the correlation coefficient matrix? What function did we use for correlation coefficient matrix? CORR. Correlation coefficient matrix will be given by this function, and this there are other functions which are available in yes, other modules like numpy, scipy. Okay, these modules also have functions to calculate correlation coefficient matrix. We'll go to that topic in the future in the further classes, right? So for time being, this is what we have understood yesterday, and I hope no questions. So let us proceed to the next topic. Okay. Uh, and yes, this is very important, friends, because this is the place where generally people get a lot of questions. Because if you pay attention, it's very easy to understand all these steps. But if you don't pay any kind of attention, or just attending for namesake, that doesn't you at the end of the day we have to grab some concept. We are here to gain knowledge, right? So I want their attention for the coming 2 3 days especially, right? So the next step, as per crisp mlq. So crisp mlq, cross industry standard process for machine learning with quality assurance. For any machine learning project, we'll follow a cycle, and that cycle methodology is named as crisp mlq, right? So in crisp mlq there are in total 6 phases, and we are currently in which phase, friends? We are currently learning which phrase of crisp MLQ. Are we in third phase, fourth phase, or fifth phase? Under which phase of crisp MLQ we are currently working on? Use chart. Second phase. Good. No, we are not in the fifth phase. We are in the second phase. What is the first phase called? Business and data understanding. Right. What is the second phase called? Second phase is nothing but data preparation. Third phase, model building. Fourth phase, model evaluation. Fifth phase, model deployment. Finally, monitoring and maintenance. Right. Good, 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 good. Huh. Now we are actually learning phase two. Under phase two, we completed EDA, one of the subphase of data preparation. You know, that four moments and these data visualizations together will be part of EDA. Then next to EDA, we have data cleansing, also called as data pre-processing, also called as data munging, also called as data wrangling. All of these different names, you know, they sound differently, but the meaning is same, right? So this is a very crucial step with respect to phase two. Not only with respect to phase two, with respect to the entire methodology. The reason is, if we clean the data properly, the model, when you try to build a model on the clean data, the results will be good, the output will be good. Okay, what if the cleaning is not done properly? So the output will not be good, and you are supposed to redo this subphase again. So data cleansing is a very crucial step with respect to crisp mlq. And today we are going to start the data cleansing part. In total there are 9 subphases, 9 topics that are present in data cleansing. The first one is typecasting, second one is handling duplicates, third one is outliers treatment, fourth one is zero and near zero variance, fifth one will be discretization, sixth one is handling missing values, seventh one is dummy variable creation, eighth one will be transformations, and ninth one is feature scaling. So what are these? Each and every topic present over here, there is a valuable, meaning for the step. Why are we doing it? And what is the impact of it? What if we don't do that particular step? Okay, on the data, the future steps, how are they getting impacted? We are going to learn with respect to each and every step. Okay, so typecasting. Uh, I'll just give you the overview of each and every step. Then we'll start from again step one. We'll understand each and every step in depth. Right. So typecasting, typecasting is nothing but conversion of data type. In order to change the data type, okay, we are supposed to use typecasting. I hope you guys remember the data types in Python, right? So under Python, you remember the different types of data types that we have learned: fundamental data types, sequence, then list data type, tuple data type, list data type, set data type, dict data type. So all these are part of data types. Yes. So in order to convert them from one to the other, okay, we are supposed to use typecasting technique. Then handling duplicates. For suppose in our data, okay, that was shared by the client, if we have duplicates, if there are duplicates in the data, will you use the data as is for the few further steps as well? No. What is the use of having duplicates in the data? It's not required. So we are supposed to handle those duplicates. That we'll understand as part of handling duplicates technique. Then outliers treatment, very very important. What is an outlier? Outlier is nothing but an extreme value. But because of this extreme value, the entire data is getting affected. So, in some cases, I don't say all the cases, but in some cases, we are supposed to treat outliers. There are different techniques which are used to treat outliers. Might be 3R technique, winsorization, whatever it might be. So we are going to treat the outliers. Okay. Zero and near zero variance. Akhil, I think we have understood this concept as part of EDA. Yes, my friend. Variance is what we have understood with respect to EDA. What is variance? Variance is nothing but the spread from the center. Am I right? Yes, the average spread from the center. Because variance formula is given as sigma of summation of x minus mu whole square by n. This is nothing but this is approx is equals to summation of x by n. What is this formula? For which measure did we use this formula? Mean? Yes. So this is nothing but mean, average. What do you mean, Akhil? I mean to say that average formula, if you observe properly, instead of x in the formula of mean, in place of x, I have x minus mu whole square. Oh, yes, you are right. So that means variance is nothing but the average spread from the center. Okay, perfect. What does this mean? Zero and near zero variance. That means variance if it is zero, or variance if it is close to zero, near to zero, such kind of columns should be removed from the data. But why? Why should I remove such kind of column data? Why should I remove them? The reason is it's very simple. If you understand properly, you'll get the answer. In EDA, what did we learn? First moment, second moment, third moment, and fourth moment? Yes. First moment is calculating or giving me the center value. Second moment, third moment, and fourth moment, together it is giving me, the distribution. Together they are talking about how the data is distributed. Okay, so that distribution together you are understanding, from second moment, third moment, fourth moment, fifth moment. But what is this distribution? This is nothing but again sigma is nothing but square root of variance. Yes. If the variance itself is zero, obviously square root of zero is again zero. Then standard deviation will be zero again. If standard deviation is also zero, okay, then what can we interpret? We can interpret that there is no spread in the data. Am I right? There is no spread in the data. If there is no spread in the data, what we are going to study, or how is the data useful for us? Okay, so we'll talk about more with respect to zero and near zero variance in depth when we do hands-on. So zero and near zero variance features should be omitted from the data, right? Next comes discretization. What is this discretization? Discretization is nothing but binning, grouping. Okay, so in short, discretization is nothing but it's a technique used to convert continuous data into discrete data. Okay, so again, as an overview, we are actually trying to bin group. Fine. Handling missing values. If we have missing values in the data, we are not supposed to take the data as is and proceed to the next phase. What is the next phase? Model building. So, what do you mean by model building? You are building a machine, you are building a model which will predict you the output. Am I right? Yes. So, when you are going to build a model, and if you train your model on such kind of data which has missing values, what does your model learn? Nothing. So, majority of the models, they does not accept missing values in the data. So we will handle the missing values present in the data. We'll understand. Hold on, no worries. Then dummy variable creation. Dummy variable creation. What is a variable? Variable, don't go to Python variables. I'm talking about variable with respect to analytics. In analytics, variable is nothing but column. Column has multiple names, friends. Feature, column, variable, all of them are same attributes. Okay, so dummy column creation. We will create some dummy columns. Oh, but what is the purpose? The purpose is, if we have any non-numeric data, categorical data, and if such kind of non-numeric data or categorical data, if you want to include in this model building, you have to convert them into numeric form. Why, Akhil? We'll discuss. What is the purpose? We'll discuss. Right. Next to dummy variable creation, we have transformation. The name itself is telling transformation. That means you are transforming something. That something is nothing but data. Why should we transform? Again, hold on. This takes lot of time, and something that I expect from you is your patience. We learn one by one. Right? One by one, we are going to learn together. Perfect. And the final one is feature scaling. Feature. So just now we discussed the other name for column. So obviously this is nothing but column scaling. What is this column scaling? Am I going to measure the size of the column using a scale? How big the column is? No, friend. We will try to scale or shrink the columns, all the columns present in the data, to a particular scale. Okay, so why is this important? What is the purpose of doing feature scaling? We'll discuss. Right? So this is just the overview of each and every technique, each and every step present in data cleansing. But I'm just clearing a question that generally people get over here. Should all these 9 steps that we have over here should be done as is, one by one, in the same order on the data? No. There is no such kind of rule. But in general, the best practice is following the same order, one by one. Okay, so yeah, we'll discuss transformation, feature scaling, to the depth we are going to learn. I'm just overview, right? So I can't give more than that. In the sense, we have time as a constraint. For time being, transformation is nothing but you are transforming the data, okay, to something else. What is that something else we'll discuss? And feature scaling is nothing but you are scaling all the features to a particular scale. Why is this required? And what happens if you don't scale? Everything we'll discuss. No worries. Clear? Right. So the general question that everyone, my students keep on asking when I give the overview of data cleansing is, should all these 9 steps to be performed as is in the same order? No, friends. There is no such kind of rule. But as we discussed, an order should be followed. If you follow in a particular order, so that you will not miss any one of the steps, right? So this is what we are going to learn for the coming few days, and your patience is what something going to keep you hold on, and we'll be learning one by one, steadily and slowly. Shall we proceed? Shall I proceed to the first topic, typecasting? Yes or no? Yes. So let's proceed to the first topic, that is, you know, typecasting. Good. In the middle, just give me, your, just send the messages so that I'll just understand whether you guys are active or not. Right. So let's proceed to the first topic, that is typecasting. So, typecasting is an important step. That's what we have discussed. What is typecasting? Typecasting is nothing but it refers the conversion of data type from one data type to the other data type. So that is what written over here. So typecasting refers to converting one data type to other. Right. So if I have my data present in now, say, uh, integer, and if you want to convert this integer data type to float, yes, you can use typecasting. Then this vice versa is also possible. So we'll just take a use case and then we'll proceed. For that, what I'm going to do is I'm importing pandas, a module which is used for data manipulation. Done. Then from, for all these 9 steps of data pre-processing, we are going to use a new data set, which is cars data set. So before I load the data, okay, let me do one thing. I'll load the data, then we'll talk about the data dictionary. So I'm using read underscore Excel. This was discussed, right? Read underscore CSV is a function coming from pandas used to read the data from a CSV file. In the same way, read underscore Excel is a function available under pandas, okay, which is used to read Excel files. You observe the file format XLSX. It's an Excel file, right? So this is the path where the data set cars dot xlsx lies in my local system. I'm going to read the data present in it, and where am I going to store it? I'm going to store in an object variable cars underscore data. Done. Executed, friends. Done. If you see, this is my data set name of the variable. Then what is a type? It's a data frame. What is a data frame? It's nothing but a table, a two-dimensional object which has both rows and columns. How many rows do you see with respect to this data? How many rows do we have? Everything is available. See, whatever the data sets that we are going to use with respect to this program are available in open source. I mean, they are available in Kaggle or other, sites. No worries. Come on, friends. What is the number of rows is 428 and number of columns are 14. So let me open this data first of all and show it to you. See, this is the data that I have and it was loaded into the memory, Python's memory. And you see, what can you interpret from this? Can you interpret anything? Can you understand anything by just looking at the data? Friends, what are your observations when you look at this data frame, cars underscore data? Please use the chat, whatever it might be. Okay, then let me reveal it out. I see background color. Oh, where is the background color? So from column MSRP till length, I see background color for all the values present in these columns, but there is no background color for the first 5 columns. Why? The reason is these columns are non-numeric, categorical columns. Make of the car model, type of the car, origin, from where, which, is it continent? Okay. From which continent did that particular car originated? Then drivetrain. So whether it you generally observe, if you come from mechanical background, you will see, but how many wheels will be what in the moment. Okay, when you drive a car, uh, when you drive a car, especially you'll observe this drivetrain. Is it 4x4 or 4x2? Okay, only the front wheel or the rear wheels. So this is what we observe, right? Yes, so all of these are non-numeric categorical columns and rest of the columns are numeric. It might be it is float or integer. I see a background color for all these rest of the columns, right? Okay, so now let us understand the data dictionary. Data dictionary is nothing but understanding each and every column, friends. There is nothing new about it, right? So make represents manufacturer or brand of the car. Okay, then model is representing the specific model of the car. Type, so in cars also you will have the types, right? Is it SUV, sedan, micro, mini? So these are the different types of cars you'll observe in the market. Then the origin, which is the country or the region from which this particular car was originated. Drivetrain, that's what we have discussed. MSRP is nothing but manufacturer's suggested retail price. Okay, since this data set belongs to US, a company, this data set was gathered from US region. It is present in dollars. Okay, so if you want to convert into rupees, multiply with that number 85 or 86, whatever the might be, $1 in INR. Multiply with that number and you'll get the amount in INR. Then engine size of engine in liters. With respect to liters, what is the capacity of the engine? Then how many cylinders are present in the engine? That's what you see under cylinders column. Next to cylinders, we have horsepower, HP of the engine. Okay, then MPG underscore city, miles per gallon. This is representing the mileage, friends. Right? Within city, what is the mileage? And on the highways, what is the mileage? So obviously, the mileage MPG changes within the city and on the highway. So both of them are recorded in two different columns. And we also have weight of the car in pounds, okay, and wheelbase, the base of the wheel, okay, in inches, and finally the length of the car in inches. So all of these columns we have it, in our data set. Together they are 14. Out of 14, 5 of them are non-numeric and 9 will be numeric, right? So now let us proceed, friends. Okay, what I'm going to do is, let me go and check the data types first of all. In order to do typecasting, first I have to know what data type or for which column I have to perform typecasting. Right? So what I'm doing is, I check the data types, but before that I'm just printing a string to the console. What is the string? The string says data types before typecasting. So before you perform typecasting, what are the data types? Let us see. Cars underscore data, which is my data frame. The syntaxes, if you see, they are very simple, friends. Data frame dot d types, which gives me, the list of data types for each and every column. See, make object, model object. Object is nothing but, it's representing a non-numeric data, text data. Okay. Whereas if you see, MSRP is integer, only engine size is in float. All of the columns hold integer data type only, except engine size. Right? So can you tell me the function which was used to get the data types? Apart from d types, what function did we use so far to get the data types? Do you remember which function gave us the data types for each and every column? Come on, friends, comment, use chat. No, I am asking you the function. If you use a particular function on a data frame, it will also give you the data types in this way. What is the function that we have used in the previous sessions we discussed? How many of you remember? Oh, is my voice not audible, friends? Can you confirm over the chat? Is it audible or not? It's audible, right? There is no kind of issue. I don't have any kind of issue. So, yep. Yeah. Thanks. Thank you, friends. So it's very clear from my side. Whoever is facing that kind of issue, you have to check, your network connection properly. Hmm. Thank you. Right. So how many of you remember info function? Info function also gives you the data types, right? If you remember cars, let me, do this. See, it is also giving me the same output, but additionally it also gives you some additional thing, right? See, column column type. Hmm. It gives the complete information, yes. Then how can you miss it? It's a very important function with respect to, EDA. right? So I observe the data types with respect to all the columns. Now what am I doing is the engine size column that I have, which is present in float, I'm going to convert this engine size column from float to integer. So what is a function that is used for performing this typecasting is as type. Let us understand initially the right hand side part, then we'll go to the left hand side part of is equal to cars underscore data, nothing but the data, the data frame dot engine size. This is the column on which I'm going to perform typecasting. Okay, dot as type. So this is the function which is used to perform typecasting, and you have to specify to which type you are going to convert the data. I am going to convert it as int 64. 64, all these are representing, you know, the memory. Let us not go into that concept, but integer. I want to convert into integer, and once if it is got converted, where I have to store it? I want to store it in the same data frame, same column. Is it clear? Very simple, friends. I'm taking a data frame. In this data frame, I have the column in which the data is in float. Okay, so this information, the values that are present in the float, I want to convert it into integer using typecasting. So in order to perform typecasting, there should be a function, right? So that function that I'm using is as type. So once after the typecasting is done, once after the data got converted to integers, you have to store it somewhere. Where am I storing it? I'm storing the same data frame in the same column. So before performing it, let me show you the data. The data is like 3.5 to 2.4, 3.2, 3.5. I'll keep it here. Okay. Now let me execute this one. Done. That means data got converted. I mean, data present in engine size converted to integer. Let me open it. See. Sorry. Right. So before typecasting, after typecasting, what happened? Can someone tell me what happened? This is the data of the column before typecasting, and this is the data after performing typecasting. What do you see? Don't tell Akhil float got converted to integer. I can understand that, but what happened? What do you observe with respect to the values? What is your interpretation? Come on, friends. See, even though if you are wrong, if you participate, what happen you if you give only int? That's something that I want you guys to try. See, 3.5, which is initially in float, got converted to 3. 2 to anyhow it is integer 2. 2.4 2. 3.2 3. 3.5 3. 3.5 same. So what kind of something is done? Can I name it as rounding off? Is rounding off done? No, rounded to nearest integer is also wrong. 1.8 is nearest integer is 2. But what happened to 1.8? Ceiling is something, yes. So I can make it as like this. I'll keep my statement like this. See, friend. Floor value, good, good. Rounding down, is it rounding down? Yes, perfect. Don't assume it as it is rounding up. Okay, it just performs round down. It round downs to the nearest integer. Nothing but ceiling value. Good. Right? So this is what, as type, when you as type function is used for performing typecasting, and we have successfully converted float data to integer data. Now let me again print the data types. So what am I doing? I'm going to print a string, and this string contains a special character. What is the special character that is present in the string? Backslash n, a new line character. Okay, new line character obviously prints this entire string in a next line. So it leaves a line as is and prints the string. Now let me check the d types again. So for engine size, it should be integer. No more it is float. Is it clear? Yes. Is it clear or not? What I am doing is I'm converting the data type of a column from one to other using a function called as type. And what did we do here? I took engine size column, and using this engine size column, the data which is present in float, I'm converting it into integer. Done. Now I'll take MSRP, manufacture suggested retail price column, and the data that is present in this column has the data type as integers. But what am I doing? I'm converting integers to float. So let us see what happens. And where am I storing it? In the same data frame, same column. No new object is what I'm not going to create any new object. The same variable in the same column, the values which got converted will be stored. Done. See, previously all of them are no, they don't have any decimals. Now point 0 will be added. Clear? Simple, friends. But the question comes here. Akhil, is this an important step of data pre-processing? Not really. Not really. Until unless if you have any requirement. See, if you have any requirement of converting the data type of a specific column, only then go and perform type conversion. Go and use typecasting. If not, this is not a mandatory step that you have to do it on each and every column in your data. Okay, so let me print the data types. So if you see, MSRP will be having float as the d type, right? But in general, in very rare cases, we'll perform typecasting until unless the model for the model, if it is not accepting any specific kind of type, then we'll change the data type. Okay, again, let us not go into that concept. 3264, that's what I'm telling you, memory. In the memory, what kind of value should be set? That's what it is descending with respect to the number 32, 64 and all. That's together a different big topic. But for time being, just together, both of them hold float value only. Okay, but with respect to the memories, bytes, I have to teach all that stuff. Not required. Ignore that for now. Right, so typecasting is done, type conversion is done. Very small topic, but in general, we don't perform until unless if it is mandatory, will not perform typecasting. But the next step of data pre-processing is handling duplicates. Handling duplicates. Very, very, very important step that has to be performed on every data. The reason is we'll discuss. Right. But okay, let me do one thing. Friends, I'm going to give you a task. Focus. Okay. So I'll give a small data set and I'll ask you to identify the duplicates. Tell me the duplicates in this data set. Okay. So there are 4 columns in total. Right. So it is 1, 2, 3, 4. 1, 2, 4, 3. 2, 1, 3, 4. Then 1, 2, 3, 4. Then uh, 4, 3, 2, 1. Right. Is this good? Yes. This is perfect. So this is a small, task that I'm going to give you because you'll understand how, or first of all, what is a duplicate. Okay, so let us understand what is this duplicate. But before we understand this topic, I want you to identify duplicates from this so that I will understand what is a duplicate from your perspective. Tell me, do we have any duplicates in this data or not? If there are duplicates, tell me what are the duplicates that we have in the data. Do we have duplicates? Yes or no? But understand the data properly. There are in total 5 records and 4 columns. So, okay, good, good. Keep going. So, my friend says, yes, what are the duplicates that we have in the data? Row 1, row 4. So, row 1 and this is row 4. What about others? What about others, friend? Okay. Good. A1, B2, C3, D. No. Okay. Anyways, I got good responses and even some responses also got, they gave me, some people gave me the right answer. When I ask you to work on duplicates, what did you do? Are you checking one value with the other value or you are checking with the entire row, with the same other row of the next one? Obviously, you'll take a row and you'll go to the next row. 1, 2, 3, 4 is what I see in row 1. When I go to row 2, I also see the same values 1, 2, 3, 4. But are these values in the same positions like row 1? No. If they are in the same position, then we can say it as a duplicate. I observe the same record like row 1, you know, it is similar, that is row 4. Row 4 is similar to row 1. So this is a duplicate, or this is a duplicate, because we don't know whether 1 is duplicate or 4 is duplicate. But I can say that there is one duplicate in the data. Don't assume, or don't just think of the values. Here I have one, here also I have one, so under A 1 is a duplicate, under B 2 is a duplicate. No, that is not how you have to understand duplicate sprint. Duplicates are nothing but the values with respect to the rows. If they are observed in the same positions like row 1 and row 4, then yeah, with respect to the cell level, the position, then we can call it as a duplicate, right? So what do you observe from this? I observe that row 1 and row 4 both are same, both are same. So what does this mean? Either we keep, either we have to include only row 1 or row 4 but not both. What is the use of keeping both? Nothing. So initially such kind of duplicates should be handled. Okay. But why again? What is the purpose of identifying or removing, dropping these duplicates? Okay. A good question that was raised. Here there is only one duplicate. What if your data has 1,000 duplicates? Will you still proceed with the duplicates? Don't do it. The reason is these 1,000 duplicates that you have it in your data, obviously they'll add some computational burden on your system. Or in short, apart from computation burden, in short, I can say that you are keeping on giving the same information to the model, to this equation, which will be framed in the back end of phase 3 of crisp mlq. You are time again giving the same values. So when you give the same values time again, obviously only that particular record will be learned more to the model. So don't do it. You have to handle the duplicates, right? So the answer is row 1 and row 4. Okay, so some people, depending on you, they are telling row 0, row 3, both are, all of them are same. But duplicate is nothing but, taking, you are looking out for the entire record, not only a single value of that particular row. The entire record should be same with respect to their places, their position. Right. So this is what duplicate mean. But now comes the question. Akhil, in this data, is row 1 duplicate or row 4 duplicate? Should I keep row 1 or should I include only row 4? What should I do? It's up to you, my friend. Either you include row 1 or row 4, but don't keep both. You remove either row 1 or row 4. Okay, so what I'll do is, I'm taking a data set. Okay, so I hope duplicates is what we understood. Now let us do it, on a data set. What I'm doing is, I'm importing pandas as PD. Then I have made a duplicate data set. In this data set, there are some duplicates. Yes. So in this data set, a specific data set has been created by us, and in this data set there are some duplicates, friend, and I'm trying to read this data and store it in the same variable cars underscore data. Right. You see? So this is the data set. Now tell me how many duplicates we have in this data set. Please. How many duplicates we have in this data? Is it 2? Come on, friends. By looking at this data, tell me how many duplicates we have, in this cars underscore data frame. 11. Are columns not considered? That's what. That is different topic. We will discuss it. So by looking at this data, tell me how many duplicates do you identify? Is it possible? Manually, can you check each and every record? Okay, this is not a duplicate. This is not. Can you do it like that? Impossible. Impossible, friends. Can't do it manually. Perfect. It's impossible. In that case, we had a function. We had Python. See, we are not going to do anything. Everything will be done by the Python. But we should know, what is the right function that will is going to do our task. It's time consuming, Moreover, even though if you give more time, I don't think it's possible to work on a big data set. I mean, still I have only 14 columns and there are 400 rows, 430 rows. I don't think it's possible, but say, what if you have 100 rows, 100 columns? Is it possible? Who is going to check each and every value? Impossible. So, what I'll do is, there is a function called duplicated. Okay, this duplicated function will generally work on data frames and this identifies only duplicates, friends. Properly, listen carefully. Duplicated function will identify only duplicates. It will not remove duplicates. Okay, so what am I doing is, I'm using duplicated function on which data frame? Cars underscore data, the data frame. The syntax is data frame dot duplicated function. And the output of this function will be stored in an object variable called duplicate. Duplicated function will return Boolean values. Friends, focus. Duplicated function will return Boolean values. What do you mean by Boolean values? What are the Boolean values we have in Python? What are the Boolean values we have in Python? True and false. True and false are the only two Boolean values we have in Python, right? So when you work on duplicated function, so it will give you only two values. One is true, one is false. Perfect, right? So let me execute and see the results. So this is done, okay, and the output of duplicated, function is a series. What is a series? What is a series? Because this is the output is stored in duplicate and I can clearly see that duplicate is a series. Series is a one-dimensional object. In short, it's a column. It's a column which has multiple rows. How many rows you find? I see 431 rows. Yes, only one column. So let me open this. And if I open it, I see only Boolean values. False, false, false. I see true. I see true here. Again, I'll go down, see false, 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 keep on going. It is false. So, what do you understand, my friend? Again, I see a true. Where is the true? Ah. What do you understand? True, false. What does that mean? There is a meaning for it. Again, there is a true here. So, can you go for a wild guess? What is true? What is false? That was, observed with respect to the output of duplicated function. Just go for a wild guess. I'm not asking about the values of true and false in Python. I'm asking you what does true and what does false represent under this Boolean series. Good. True means it's a duplicate record. Okay. And false means obviously it's not a duplicate record. Will you? Okay, whatever my friend says is perfect. Good. Obviously, excuse me. So let me go with record 26. It's true. So that means record 26 is a duplicate. Okay. In the same way, wherever I have true, that particular record is a duplicate. Perfect. Akil, I understood. Okay, that's good. But since I had only 431 records, it's easy for me to go and check how many truths are there. I'll go and check manually. I'll get the count. I'll count how many truths. What if I'm working on thousands or lakhs of data? Will I go and check or will I go and count each and every true? Impossible, right? So how can I get the number of duplicates present in the data array? How it is possible for me? If that is your question, what is the uh, what what logic can we use or what logic can we come up with to get the number of duplicate rows present in the data set? I'll give you some time, think properly and come back. How can we get the number of duplicates present in a data? Since this is small data, I'm going and counting number of truths. True is a duplicate, perfect. But what if I'm working on, say, 1 lakh records? Will I sit and count how many truths I have? No. That's fine. False means it's not a duplicate. True means it's a duplicate. But my question is, how can I get number of duplicates in the data? Think. We know the answer, friends. Just think. If you are good at basics, you have to tell me the answer. Think. Or should I reveal? Okay. I'll give you a hint. Oh, good. Some function, yes. Perfect. See, what I do is false is nothing but 0. What is the value of false in Python? Count function, okay, good. But in order to make it very simple, in Python, false is internally treated as 0 and true is nothing but 1. So I'll sum up all these values present in the series. So I'll get some n value, right? So obviously n duplicates. Clear? That is the, logic that we'll use to get the number of duplicates in the data. Is it clear? Yes. Now let me proceed. So what I'm doing is I'm printing a string to the console, Boolean series indicating duplicate rows, and then I'm printing the series as is. You see, I have printed, and I can clearly see that 431 record is true. Index 430 is nothing but 431th record. Right. So in order to get the number of duplicates present in the data, I'll go with the sum of duplicate. Okay. So sum of duplicate will return me the number of duplicates present in the data, and I'm storing it to a variable. So how many duplicates you see? I see 3. There are 3 duplicates. Okay, perfect. Let me, you know, print that string to the console. I'm using f string, friends. There are in total 3 duplicates, right? Yes, perfect. What am I doing here then? I have used the same duplicated function, right? I used duplicated function in line number 65, which gives me the duplicate, whether the particular row is a duplicate or not. I'm using the same duplicated function again, but this time, I don't see any, I see a different parameter coming into the picture. What is this parameter? Keep. What is this keep? Keep is equals to last. Keep is equals to last. And I'm storing the values of keep is equals to last. No, I'm not counting. There is nothing counting. Okay. So keep is equals to last. I'm taking a parameter from duplicated function, and I want to get the duplicates. I want to store it in duplicate underscore last. Done. So duplicate is where I have achieved from line number 65, and duplicate underscore last I have achieved from line number 76. What is the difference between these two? Because both of them are achieved using duplicated function only. There is one more, line number 80. Duplicated, keep is equals to false. What is this? Let me execute. So 3 objects are created using duplicated function. But the thing is, the first one is created using duplicated function where I did not use any kind of, parameter inside the function, and in the second object, in the second variable, I have used last. Keep is equals to last as one of the parameter inside duplicated function, and keep is equals to false as one of the parameter in the third object. What does that mean? It means, but before I explain, I want you guys to notice that. So this is the output of, you know right. So 3 outputs. I have bought it here. Duplicate all, duplicate last. Okay, this is, I keep it here. And this is the third one. 1, 2, 3. Okay. Focus, friends. Don't get deviated. That's what I told. Right. So you see the Boolean values. Akil, yes. In the first, this, whatever I see, Let me keep it like this. Why am I taking this much time, for your proper understanding only? Right, focus. See, this is what we have achieved for the first time when we use duplicate function, and this is what we achieved when we use duplicate function with keep as last parameter, and this is for duplicated function with keep as false. What makes the difference with respect to the output? Is there any difference, friends? Is there any difference with respect to the output, or all of them are same? What do you observe? You observe properly record 7 in all the three cases. What do you see is the record, I mean index 7 value for all these three. Is it same? Why? Why it is not same? For duplicate, here it is false, here it is true, whereas here also it is true. What does that mean? In this case, it is not a duplicate, but here it is a duplicate, but here also it is a duplicate. What does that mean? Hmm. It means, we have to study the documentation. Right, let me tell you. So, duplicated. Let me open the documentation of duplicated. We'll wind up the class, no worries, but I want you guys to focus. Duplicated documentation. See, this is the official documentation of duplicated. Focus. So under duplicated, you see the syntax is data frame dot duplicated. That's what we have used. Sorry. Data frame dot duplicated. Data frame dot duplicated. What do you see with respect to inside the duplicate? Inside duplicate, there are two parameters. One is subset and the next one is keep. Okay, let us understand what does duplicated function returns. It returns a Boolean series. Yes, I also got the same. A Boolean series is what I got. Perfect. Denoting duplicate rows. Yes, obviously inside this series, if I see a true value, it is a duplicate, and if it is false, it is not a duplicate. Perfect. Now let us understand the parameters. Under parameters, the first one is subset. Am I using subset anywhere? No. If you don't use subset, it takes by default none. Okay, what is this subset? Subset means, do you want to use this complete data frame as is, or do you want to use only a subset of it? No, I want to use the complete data frame. So I'm not using the subset parameter. So I'm ignoring it. Now let me come to keep parameter. What if I don't take keep parameter? If I don't take keep parameter, by default it takes first. So did I take keep parameter here? No. So even though if you don't consider keep parameter, by default it takes keep is equals to first. What is this first, last and false? Keep by default takes first. What are the other values keep can take is last and false. Okay, let us understand. Determines which duplicates to mark. First means mark duplicates as true except for the first occurrence. The first occurrence within the data will not be marked as true, whereas the rest of the occurrences will be marked as true. In the same way, last, mark duplicate as true except for the last occurrence. The last occurrence will be marked as false, and rest of the occurrences will be marked as true. And finally, false, mark all of them as duplicates, true. Is it clear now? Why there is a difference with respect to the output for these three? I hope it's clear now. When you are changing this value with respect to keep, okay, so you know, obviously the duplicates true false get changed, right? So this is what we have understood with respect to duplicated function. But what is my aim? My aim is not to just identify the duplicates. What is my purpose of working on this step two? To remove or handle the duplicates. So there is a function called drop underscore duplicates. Drop underscore duplicates will drop the duplicates from the data. Okay, that's what. See, on what basis true duplicate will change? It is changing based on the parameter that you are using, the value that you are using for keep parameter. If you don't keep the right, when you even though if you are not keeping any value for key parameter here, but still by default it takes first as the value. Okay, don't get confused. Right, now I'm using drop duplicates. So this is going to drop the duplicates from the data. So when I execute this, this will remove the duplicates from the data frame and it will store the data in a new object, that is data underscore first. So tell me what will be the size of data underscore first. When I execute line number 84, what will be the size of data underscore first? Come on friends. If I execute line number 84, the duplicates present in cars data will be dropped. Okay, so obviously we understood that there are three duplicates, right? So three duplicates will be dropped and the output will be stored in data underscore first. So what is the size? I'm expecting you the size. 428 is what my friend says. So let me check. Am I getting 428? Yes, it is 428. 428, but the columns remain same. Are we dropping any column? No, I'm just dropping the duplicate row. Okay, then I'll do the same, but this time I'm changing the parameter. So keep is equals to last. So that means keep parameter is also available in drop underscore duplicates function as well. Okay, so again, drop underscore duplicates function will remove duplicates depending on the parameter that we pass inside. So I'm not passing any parameter here. By default, keep takes first. The first one will be marked as the original one, and whatever we have the duplicates down to it will be marked as duplicates, and those will be removed. Those will be dropped. I'll show you the difference. See, keep underscore last. I'm keeping I'm keeping last as the value and I'm dropping the duplicates. See the size. The size is 428 by 14 and I'm also using keep is equals to false and executing. The size is, but if you see here, it is 426 because all of the original and duplicate will be removed with respect to false. If you pass false as a value for keep. Okay, so I'll show you the difference. Data underscore first. This is the first data frame. I mean the data frame that we got when keep is equals to first. And this is the data frame which we got for keep is equals to last. Now see properly. I don't have record 7 in this data, keep is equals to last data frame. That was dropped because here it is a duplicate, whereas here it is not a duplicate. I'll scroll down. I don't see record 26 here, but here I'll see record 26. Probably, yes. Is it clear? So the difference that we are understanding here is when you change the parameter inside the function, see how the output is getting changed. But the ultimate goal is to remove the duplicates. Okay, don't, in general will not use false because false is also going to remove the original one. So this is not preferred. Either keep is equals to first or keep is equals to last is preferred. Right? So I'll stop the day here, and if you have any kind of questions, yes, please, no, it's time for our technical questions, and we'll also provide you the form. Please share your valuable feedback. But before that, give your valuable feedback, ask your questions because I don't think we'll provide everything, my friend. Okay, everything will be provided when you give your complete attendance. Row wise. Why are we finding duplicates row wise? Why not column wise? Good question. So the first, whatever we are doing is with respect to row wise, right? So in with respect to row wise, we should not have duplicates. In the same way, we should not have duplicates with respect to column wise also. That what does that mean? So Akhil, you mean to say that with respect to columns, we should not have any two same columns? I don't mean that. In general also, can we have two columns as same? You tell me in any data set, can you find two columns as is? Only then you can name it as duplicate, right? Tell me, my friend, what is a duplicate? Duplicate is nothing but same. So, can we identify any data set with same columns or similar columns? Impossible, right? But the data or the meaning that the column have might be duplicated. Okay, the values, not exactly the values, but the information that was stored with respect to that column might be duplicated. So we'll identify such kind of columns and we'll deal those columns in a different way. That's completely different. We'll understand in the coming classes. Okay. No, in general, see, these sessions will get prolonged. See, you have to adjust yourself and, stay back. These are going to do a lot in your. They are going to add many new skills. Say you're going to grab more knowledge by listening or by attending these sessions. So stretch yourself, friends. But if you don't have any questions, thank you so much for joining the session. And I want all of you to click on the like button and comment if you have any kind of issues. But these sessions are, whoever is attending these sessions and making these sessions very interactive, thank you so much. But in the same way, share across multiple channels, ask your friends, relatives, whomever it might be to join these sessions and grab good amount of knowledge. Right? Right. So I see no questions. Thank you so much, friends. We'll connect tomorrow and we'll continue our topics. Have a great day. See you.